Nice to see you all. Thank you, Amanda, for a very nice talk. I borrowed Amanda's slide. I will focus here on a essential question which we had within AURORA, which is, can we actually find evidence of the transfer of micro and nanoplastics from the maternal side into the placenta or either into the fetus? And this is what I will focus on. And to me, it's a rather simple and straightforward question, but I can already tell you that the answer is not simple at all. So this is what we focused on within AURORA. As Roel said, there were already reports emerging at the start of AURORA, even a bit before that, where people reported microplastics within placenta. And interestingly, these microplastics were relatively large. So they were measured, for example, with Raman or IR microscopy, which means that they were several micrometers or tens of micrometers in size. There are other reports that are using the methodology that we also use, pyrolysis GCMS, to also report plastics in the placenta. So do micro and nanoplastics indeed reach this placenta and fetus? And do they impair placental or fetal development? What are their biological or health effects? This is something that Juliette will actually focus on after my talk. To study this within AURORA, we actually did two things, which is the digestion of placental tissue. So actually trying to see if we can find micro and nanoplastics within placentas, but also to look at placental perfusion. So I will come back to this. First, for the digestion. This is the work that's been done by Laura Zoutendijk, AURORA PhD student, and team. And what we did is looking at placenta tissue, which is of course a very complex biological matrix, trying to first dissect it into smaller pieces, but then also using chemical digestion to break down the matrix in such a way that we end up with a solution which is completely transparent. That's one. But also which can be used then for the assessment of micro and nanoplastics. This means, simply said, that you need to destroy practically the placenta, ideally back to atoms, whereas we want the plastics that are potentially in there to stay intact. If we would destroy these, we would not be able to measure them. So this was developed, and one of the key things here was that actually an enzymatic approach turned out to be best. And Laura tried a lot of combinations, actually. Here you can see filters, which we used after the digestion. And if you see a very clean filter with the green check mark, that means that the material was digested in such a way that it could actually pass over this filter. So it was broken down into very tiny pieces, let's say. But you can see that on one axis we have buffers, on the other ones we actually had enzymes, that there were many combinations which were not ideal. And so we, with the proteinase K, we actually found our optimal digestion protocol. So that was one. But then, like I said, we also need to show that the plastics are actually intact if you want to measure the plastics from the placenta afterwards. So this was done by spiking the placentas with fluorescent micro and nanoplastics. And after the whole digestion protocol, we looked at these particles with fluorescent microscopy. First of all, to see if all the particles that we put in are actually traced back after the digestion. And this was the case for most of the steps. And also to see if the particles were still identical. So if their size and shape, for example, did not change. And this also seemed to be the case. And now, interestingly, you see an image here, which is an electron microscopy image on a filter. This is a nano filter. And here, in the white marked circles, we actually find back these spiked polystyrene plastics after digestion. And you can also see the holes, actually. The fact that we can see them proves that the digestion was quite successful. And going towards smaller and smaller and smaller particles, you can imagine that the digestion becomes more and more important, but also complicated. You need to break it down more and more to find the smallest particles possible. So that was step one. Step two was looking at the actual transfer of micro and nanoplastics over the placenta. And this was a collaboration with the University of Eastern Finland. What was done here is placenta perfusion studies. So placentas which were donated were connected after birth quickly to a tubing system in which liquid could be transferred over the placenta. This liquid was also spiked with these fluorescent micro and nanoplastics. in this way, we could see if the plastics would actually go over the placenta and end up at the fetal side, starting from the maternal side. And what was interesting is that we found, first of all, that there were not so many micro nanoplastics even at the maternal side left, but that the transfer to the fetal side was limited. So we found very, very little transfer, but it was likely there. And part, like I said, of the micro nanoplastics seemed to be gone, which we showed later that this was specific to size. So where did they ended up? We actually found that most of these fluorescent micro nanoplastics ended up in the placenta tissue, actually. So this is research still ongoing towards the end of AURORA. We are still looking into understanding how this transfer is happening and where the micro nanoplastics end up. But what we already found is that, for example, albumin, which is the protein most abundant in blood, can play a large role in if these micro and nanoplastics cluster, for example, and therefore might pass the placenta more easily or not. So with that, I would like to summarize this part. State what we found within AURORA, which is that digestion protocols are really vital to assess micro nanoplastic concentrations within, for example, placenta tissue. And we've worked hard on this to try and optimize this. I think we did a good job there. These perfusion studies that we showed give you very valuable insights on the transfer. We do see some transfer to the fetal side, but it's also, like I said, quite complex. So we hope within the rest of AURORA to get more complete answers on the questions that we still have there.